So many times in your engineering classes, you'll come up against a situation like this. You'll do your sum forces x, y, and z. Maybe if you're in statics, you'll have 3 equations, and maybe you'll have 3 unknowns. And maybe these 3 unknowns will represent the different forces in 3 different beams, but you'll have 3 unknowns. Here I'm just having x, y, and z. And of course you want to solve for what these 3 numbers are. And instead of having to do the old-fashioned way, like, get x by itself here, get x by itself here, and plug them into this equation and do all that sort of thing, you can basically take the information of this equation, put it into a matrix in your calculator, and just let your calculator very quickly solve for what x, y, and z are. And you definitely want to do this because, as you can imagine, as you get into the more advanced classes, you'll be analyzing systems that have a lot more equations and a lot more unknowns. So one thing I just want to mention, you got to make sure these are linear equations or this won't work. Remember, a linear equation is like this. We have a constant here, and our variable is raised to the power 1. Notice how each of my variables is raised to the power 1. If any of these were raised to a different power, like 2 or even radicalized, this whole procedure that we're about to get into would not work. So just make sure all of your equations are linear equations. And if they are, you can solve this system of equations using matrices, and that's what we're about to get into. So, your first step, you want to put your system in this form. Notice that I have all of my unknowns on the left, and all of my constants are on the right-hand side of the equal sign. This will always be your first step. And you want to make it nice. You want to make it nice and organized such that the first terms will have your x's, your first unknown. The second terms will have your y's. Looks like there's no y in our third equation here. And your third term will be your z's. That really helps. So just put it in this more organized standard form here. Next, we're going to put all this information, basically, into these 3 matrices. We'll start with this one right here. This is known as our solutions matrix. You put our unknowns in here, x, y, and z. So we'll just call this matrix B. And many times it's referred to as the solutions matrix. So we're all prepped and ready to go. We're basically going to take each equation and encode it into our matrix. So I'll call this equation 1. Equation 1 will go literally in this row right here. And here's how we do that. We take the coefficients of our unknowns and put them here. So for equation 1, what's the coefficient of the x? That'll be a positive 3. So 3. The coefficient of the y, that'll be a positive 8. 8. Coefficient of the z, positive 2. 2. And then, what's on the right-hand side of the equal sign, the constant, that will go here. So this is commonly known as the right-hand side matrix, the RHS matrix. You may hear it referred to by a different name, but that's how I was taught. And this one right here is the coefficients matrix, because it has the coefficients of our unknowns. We'll just refer to our coefficient matrix as A and our right-hand side matrix as C. And we just proceed in this manner. We're going to look at equation 2, and we're going to encode that into this row of our matrix system. So let's look at our coefficients. Coefficient of the x, negative 4. Coefficient of the y, that is an invisible 1 right here, so 1. Coefficient of the z, this is a bit tricky. It's going to be negative 5. Don't forget those negatives and positives, those signs. And on the right-hand side, that constant, that this is all equal to, negative 60. And third equation, same thing. The coefficient on the x is 2. The coefficient on the y, Got to be careful here. There is no y in this equation. Well, actually, in a sense, there is. It's just 0 times y. Because if you do 0 times any number, it's just 0. So in a sense, that y is there. So it's a bit of a trick there. If you ever see a variable that's not in the equation, its coefficient is a 0. Watch out for that. So the coefficient of y in equation 3 is 0. And the coefficient of the z is 3. And the right-hand side is 31. Alright, so we have successfully taken the information of this big equation system and put it into this matrix statement. And what this says is matrix A multiplied by matrix B is equal to matrix C. So matrix A times matrix B is equal to matrix C. So now all we want to do is solve for matrix B. Now if this was regular algebra, no problem. Just divide by A on both sides. For weird reasons that are not known to me right now, you can't do this. I'm not sure why, but matrices are a bit weird. Matrices don't allow you to do matrix division for whatever reason. To get B by itself, you have to do this. B will equal to the inverse of A times C. Now this right here means the inverse of A. How I make sense of it is this. Say I had a 5 and I raised it to a negative 2 or something like that. What it really means is 1 over 5 to the 2. Kind of a similar thing here, I like to tell myself. We have C, and A to the negative 1 is really just A to the 1. So in a sense, we kind of are doing C over A. At least that's what the symbols look like. But doing this will get you B. Will get you our solutions matrix, X, Y, and Z. So all you have to do now is use your calculator, input those values in for some matrix A, take the inverse of it, multiply it by matrix C, press the equal sign, and you'll have B, your answers for X, Y, and Z. And if you actually were following with this example and doing it, you would get 2 for X, you would get negative 7 for Y, and you would get 9 for Z. Alright, very, very powerful technique here. I highly recommend you getting used to this quick matrix approach for solving a system of equations with unknowns. This technique works for however many unknowns you could ever want, 3 unknowns, 4 unknowns, 5 unknowns. That's the power of it. Just make sure before you do this technique, you make sure your equations are linear equations. Alright, hope this video made sense. If you have any questions, feel free to ask them in the comments.